Hello everyone, I am Sanatan. Today I am going to discuss about satellite network as how they are present around the earth, its orbit or path of rotation category as some of its advantages and disadvantages. So let's get started. Introduction. A satellite network provides communication from one point on Earth to another between nodes, and some of these nodes are satellite or earth station or end user terminal or telephones. As we know that Moon is also a satellite, but it only rotates around the Earth and shows the properties which are also used for communication or for the purpose of data transfer. In this presentation, we will talk about how the artificial satellite orbits around the Earth and help us in transmitting data. The first satellite launched in this space was Sputnik 1 on October 4, 1957 by the Soviet Union. It was about the size of a beach ball, weighted only 83.6 kg or 183.9 pounds, and took about 98 minutes to orbit the Earth on its elliptical path. Now, moving towards the second slide. Orbits of the satellite. An artificial satellite needs to have an orbit, that is, the path along which it travels and rotates around the Earth. The orbits can be equatorial, inclined, or polar. In figure 1, we see how the satellites orbit around the Earth in three different ways, such as equatorial, inclined, and polar. Now, as the satellite orbits around the Earth, there is a time period. So, this time period is obtained by the Kepler's law. That now the time period to make a complete trip around the Earth, known as period, is determined by the Kepler's law of period, which is equal to T is equal to 4 pi square by gm into r cube. Here, the values are T is equal to the time period, G is the gravitational constant, M is the mass of the central body, and R is the radius. To see more about the Kepler's law of period, we can look forward to the following example. What is the period of the moon according to the Kepler's law? Solution. The moon is located approximately 3,84,000 km above the earth. The radius of the earth is 6,378 km. Now, applying the Kepler's law, we can find out that the period will be around approximately 1 month. Now, moving forward, fourth slide. Category of satellite. The satellite can be categorized into three different types based on the location of the orbit. These orbits are chosen such that the satellites are not destroyed by the high energy charged particles present in the two Van Allen belts. The lower Earth orbit is below the lower Van Allen belt in the altitude of 500 to 2000 km. The medium Earth orbit is between lower Van Allen belt and upper Van Allen belt in the altitude of 5000 to 15,000 kilometers. The medium Earth orbit is between the lower Van Allen belt and the upper Van Allen belt. Above the upper Van Allen belt is the geostationary Earth orbit at the altitude of around 36,000 km. Below the geostationary Earth orbit and above the upper Van Allen belt is the Global Positioning System (GPS) satellite at the altitude of 20,000 km. From figure 3 we can see the how the LEO, MEO and GEO, which is known as low Earth orbit, medium Earth orbit and geostationary Earth orbit, are present, in which the satellites orbits around the Earth for transmitting the data. As the data is being transmitted, so we require some frequency bands on which it should be transmitted. So, frequency bands. Two frequencies are necessary for communication between a ground station and a satellite. One for communication from the ground station on the Earth to the satellite, called uplink frequency, and another frequency for communication from the satellite to a station on the Earth, called downlink frequency. These frequencies reserved for satellite communication are divided in several bands such as L, S, C, Ku, Ka, etc. are in the gigahertz in bracket microwave frequency range. Higher the frequency, higher is the available bandwidth. Towards the right side, I have made a I have made there is a column in which there is band, download frequency, uplink frequency, and the bandwidth in which the data is transmitted. So moving forward to the now some of the categories which of the satellites of the orbits. Now first one is the low Earth orbit satellites. LEO satellites are much closer to the Earth than GEO satellites, ranging from 500 to 2000 km above the surface. Rotation period of these satellites are 90 to 120 minutes with a speed of around 20,000 to 25,000 km. LEO satellites don't stay in fixed position relative to the surface and are only visible for 15 to 20 minutes each pass. A network of LEO satellites is necessary for LEO satellites to be useful. Figure 4 shows that how satellite is being the medium of transmitting data from one station to the other. Here, more number of satellites are required as the time span of each satellite is small. Now, some of its disadvantages. Advantages. A LEO satellite is approximately to Earth compared to a GEO satellite gives it a better signal strength and less of a time delay, which makes it better for point-to-point communication. A LEO satellite smaller area of coverage is less of a waste of bandwidth. Now, disadvantage. A network of LEO satellite is needed, which can be costly. Atmospheric drag affects LEO satellite, causing gradual optical distortion. Now, moving forward to which is also known as medium Earth orbit satellites. A MEO satellite is in orbit somewhere between 5,000 km and 15,000 km above the Earth's surface. MEO satellites are visible for much longer period time than LEO satellites, usually between 2 to 8 hours. MEO satellites have a larger coverage area than LEO satellites, as in range larger as its range is larger than MEO, so LEO. So MEO basically application is in setup of GPS. We can say that the structure and architecture of MEO GPS is established and works on its basis. GPS example of MEO constructed and operated by US Department of Defense. At the starting of the establishment of GPS, it was only used by the US Department of Defense, but now it is available in each and every cell phone and every individual can use it. There are 24 satellites in its 6 orbits, used for land, sea and air navigation to provide time and location for vehicles and ships. The satellites in each orbit are designed in such a way at a time minimum 4 satellites are visible from any point on the earth. GPS, how it works. The trilateration principle can find your location on the earth if you know our distance from 3 satellites and known the position of each satellite. The position of each satellite can be calculated by a GPS transceiver. The GPS transceiver then needs to find the distance from at least 3 GPS satellites. Suppose all the GPS satellites and the receiver on the earth are synchronized. Each of the 24 satellites transmit a complex signal, each having a unique pattern. The receiver measures the delay between the signal from the satellite and its copy of the signal to determine the distance of the satellites. Using this, we can know the location of any individual or the person as the satellite sends the signal to the sender, and that sender send back that distorted signal to the satellite. Now some of its advantage and disadvantages. Advantage: MEO satellites Longer duration of visibility and wider footprint means fewer satellites are needed in a MEO network than a LEO network. Shorter time delay and stronger signal than a GEO satellite. Now, disadvantage. A MEO satellite distance gives it a longer time delay and weaker signal than a LEO satellite, throughout not as bad as a GEO satellite. Now, moving forward to the third satellite categories as GEO, which is geostationary Earth orbit satellite. These satellites are in the orbit of around 36,000 km or 35,000 km above the Earth's surface along the equator. Objects in the geostationary orbit revolve around the Earth at the same speed as the Earth rotates. This means geosatellites remains in the same position relative to the surface of Earth. One geosatellite cannot cover the Earth. It takes minimum 3 satellites equidistant from each other. The figure shown in this slide gives us how the geostationary satellites are placed around the Earth in the pattern, so that as pattern, which means that one satellite is not enough to cover the Earth. So we need more than 2 or 3 satellites in a pattern so that it can cover the whole Earth. Its advantage and disadvantage. Advantage: a geosatellite distance from Earth gives it a large coverage area, almost a fourth of its Earth's surface. Geosatellites have a 24-hour view of a particular area. These factors make it ideal for satellite broadcasting and other multi-point applications. Disadvantages: a geosatellite's distance also causes it to have both a comparatively weak signal and a time delay in the signal, which is bad for point-to-point communication. Geosatellites centered above the equator have difficulty broadcasting signals to near polar regions. Uh, so as we have seen as how the orbit of a satellite is there, its time period and its category, and also the frequencies band on which the data is being transmitted. Now at the last we see some of the advantages and disadvantages of the satellites. Now the advantages of satellites: the coverage area of satellite greatly extends that of a terrestrial system. Transmission cost of a satellite is independent of the distance from the center of the coverage area. Satellite to satellite communication is very precise. Higher bandwidth are available for use. Now the disadvantage of the satellites. Launching satellites into orbit is costly. Satellite bandwidth is gradually becoming used up. There is a large propagation delay in the satellite communication than in a terrestrial communication. So, for the today's slide, thank you.